Good afternoon and welcome to our second webinar of 2024 for the Strong Foundations Professional Development for Geotechnical Engineers Non-Technical Webinar Series by the CGS YP Committee. This is the sixth webinar since we started the series last year. My name is Leonardo Paranhos. I am a graduate student at Western University based in London, Ontario. Thank you for joining us today. Some housekeeping items. Please enter your questions in the Q&A field. We have recently switched to the Teams platform, so please be patient with us while we learn the platform. If we have time at the end, I will read out questions to our speaker. Lastly, please feel free to join our LinkedIn group named CGS Young Professionals Committee to keep up to date with our initiatives. With that, it is my pleasure to introduce our speaker for this webinar. We're thrilled to welcome Matthew Yip, M.Eng, P.Eng, Principal and CEO of Kontur Geotechnical Consultants, Inc., a leading geotechnical engineering firm. He brings over 17 years of dedicated experience to the industry. He earned his bachelor's and master's degrees in geological engineering from the University of British Columbia. Throughout his career journey, Matthew has immersed himself in all aspects of geotechnical engineering, from hands-on field and laboratory programs to comprehensive engineering analysis and design. His diverse portfolio spans a wide spectrum of projects, encompassing land development, healthcare and educational facilities, municipal infrastructure, and emergency response initiatives. Matthew's expertise extends from engineering design to construction oversight, materials testing, and effective project management and leadership. Matthew remains deeply grateful for the invaluable support and guidance he has received from colleagues, both past and present, which has enabled him to progress from field engineer to his current roles as principal and CEO. These collaborative relationships have been instrumental in shaping his career trajectory. Everyone, Matthew Yip.
Thank you, Leonardo. Thank you, everyone, and welcome to this webinar, Rock Solid Career Growth, Insights for Geotechnical Engineers. This is my first webinar that I presented, so if I make any mistakes, maybe go easy on me. Anyways, I hope over the next maybe 35 to 40 minutes, I don't think I'll take the whole time. I hope you'll gain some insights about navigating a successful career in geotechnical engineering, which I basically am drawing from my own experiences over the past 17 years. So a quick overview of the webinar. I'd like to touch on some of the key points that I have found to be useful in my career as a leader, a manager, and a geotechnical engineer. So the outline of the webinar includes a brief introduction, which we kind of went over already, about who I am and what my experience has been. Kind of my take on what is geotechnical engineering and the role of the geotechnical engineer. Some discussion on potential career paths or opportunities that young geotechnical engineers can choose from. Into the main part of the presentation or webinar is a summary of kind of the key proficiencies I believe will foster strong career growth in the geotechnical consulting world. And then we'll go over some kind of non-technical tips on how to overcome challenges and build your personal resilience. And then kind of wrap up the webinar with any questions that anyone may have. So Leonardo did a good job about this next slide, so I'll go really quickly over it. But my name is Matthew Yip, registered professional engineer in BC and Alberta. I did my bachelor's in applied science and geological engineering and my master's of engineering at UBC. And I'm currently the principal engineer and CEO at Kontur Geotechnical Consultants. Kontur is a small but growing engineering and testing firm with a staff of about 50 engineers, technologists, technicians, and administrative support. Our main operations are based in the Metro Vancouver area, specifically Port Coquitlam. with satellite offices in Squamish and in Cranbrook, BC. As we kind of touched on, I've worked as a geotechnical engineer for more than 17 years. My roles range from field engineer, project manager, principal, and now CEO. And my technical work or competencies have taken me from learning the basics of soil rock identification and classification to learning how to develop and perform comprehensive field programs, lab programs, um, refining my observational skills, completing a variety of geotechnical analysis, seismic assessments, landside hazards, excavation, shoring, retaining wall embankments, and inputs for shallow and deep foundations. So my career path has really seen me develop as more of a overall or rounded engineering consultant rather than a specific technical expert on a specific geotechnical topic. And then outside of work, who am I? Maybe I hope to think it's the most important, but I'm a husband of 15 years and a father of two very busy young daughters. So what is geotechnical engineering? I think, as we all know, geotechnical engineering, the textbook definition involves the application of the study of soil, rock, groundwater to assess the interaction between these materials and the structures or buildings we build upon them. Geotechnical engineering also involves the production and use of engineered materials like aggregates, crushed aggregates, asphalt, concrete. So on a daily basis, geotechnical engineers apply their academic knowledge and experience and characterize a wide range of sites from a geotechnical perspective, assessing the site topography, surface conditions, subsurface conditions, and then based on our interpretations and our characterizations and the expected or anticipated behavior of the materials, we provide recommendations and inputs to develop sites and to provide good, strong foundations for various infrastructure facilities or buildings. So we can say that geotechnical engineers play a crucial role in ensuring the safety, the stability, and the longevity of infrastructure and building projects, providing solutions to challenges posed by the varying site conditions. So textbook kind of answer, I guess. But further to the technical role, geotechnical engineering, like any other engineering discipline, requires the application of a lot of non-technical elements that are essential for the successful delivery of a project and for the continuance of good professional practice. Geotechnical engineers must be mindful of these other aspects and not overlook them, which I think we often do because we like the technical nature of the work, we like the projects, we like looking at soil and rock. But these other aspects include, upholding or practicing the engineering in a safe manner to protect the public. Are we considering the ethical, societal, cultural influences of a project? We should be, implementing or using sustainable practices in our day-to-day work and identifying potential environmental impacts of a project. We should always be ensuring we meet or exceed any regulatory requirements, and then we should manage our risk, not just our own personal risk or the risk of the company that we work for in terms of liability or litigation, but managing the risk of a project for your client in terms of what are the knowns and unknowns that they may be faced with and how that influences their perspective on a project or what might mean as a successful completion of a project. And then lastly, using good project management tools and methods to make sure that you can complete the work and the task at hand. So the combined technical and non-technical aspects of geotechnical engineering for any project, we all can see that it can dramatically influence the successful outcome of the project. So a couple examples, which I just really took from Google or the internet, in BC, and they're mostly BC based examples, but here we have Highway 1 or the Trans-Canada Highway near Golden, BC. This is a section that was recently constructed through the Kicking Horse Canyon. And as you can see, it's steep hillside, mountainous terrain, likely some unstable ground here. And one can see that a geotechnical engineer must have had a great deal of input to permit this project to go forward. And then you can kind of start recognizing all the different challenges that are associated with a project like this. The span of the highway is pier supported on a steep slope. You can see, rockfall barriers above the highway to protect the traveling public. So there's a lot of things that go into a project like this that are highly dependent on a geotechnical engineer. Again, another highway in BC. This is in November of 2021. After BC went through a series of atmospheric rivers or heavy intense rainfall, and there was a lot of flooding, a lot of landslides that occurred. This particular one was out at Ruby Creek along Highway 7 near Hope. And there were several similar sized debris flows or landslides that came down on the highway, cutting off the highway and essentially trapping several hundred people in between these areas, or these slides, I should say. So geotechnical engineers needed to react quickly, respond quickly, assess the site for safety and stability, and then allow the crews, the highway crews, to come in and start clearing the debris and mud and reopen the highway and provide that access back to the people who were kind of stranded for a few days in between. And then a couple other examples. One on the left here is one that's kind of recently in the news in Coquitlam here, where there was an excavation failure. Whether it was a design issue or a construction issue or materials issue, I don't know the particulars, but you can see the impact that geotechnical engineering has, or a geotechnical engineer has, where this is quite a deep excavation, maybe 6-7 levels below the ground surface, and when things go wrong, they definitely go wrong. And here we can see a significant loss of soil into the excavation, and it likely caused shutdowns of sidewalks and roads and to neighboring areas. And then on the right of the screen, this one goes back to 2014 that I picked off the internet, and it's a landslide in Salt Lake City where developers come in. They've developed this nice, beautiful residential subdivision, built a bunch of new homes at the base and the top of a slope, and then a large landslide occurs, kind of more of a traditional one, I think, in this case, in terms of the rotational failure. But the toe of the landslide then basically moves out and destroys a home. So there's some significant impacts that can happen related to geotechnical engineering, and geotechnical engineers play a very important role in society about having to assess these scenarios after they've occurred, or try and assess a site before they happen and prevent these types of scenarios. So then we move on to kind of the career paths. What path do I want to take, and what are the paths as for a young geotechnical engineer? So like other engineering disciplines, there are many different career paths. And for geotechnical engineering, the kind of the primary ones, or the typical ones, include becoming a consulting engineer, becoming a contractor's engineer, working for the government or an approving authority having jurisdiction, working in research or academics, or specializing. Maybe you want to become an expert on landslides, or an expert on geotechnical earthquake engineering, or an expert on shoring, expert on deep foundations. Or perhaps you want to go into a non-technical topic and develop software that other geotechnical engineers can use to evaluate their geotechnical problems. Or perhaps it's building instrumentation and equipment to help monitor sites from a geotechnical perspective. So geotechnical instrumentation, for example. So my career path has followed the consulting engineering career path. Therefore, most of my presentation is kind of focused with that lens or that viewpoint, which is my experience. But I'm sure that a lot of the lessons that I've learned and the tips that I'm going to kind of discuss in this presentation are certainly applicable to the other career paths. Um, and I think it's important to kind of recognize that there's an abundance of opportunities for a geotechnical engineer. So, when you're setting your goals and you're trying to outline or create a framework or a roadmap, you know, understanding these different options is important so that you can um, set yourself up for to follow that and achieve that specific goal, whether it's consulting or academics or working in government. So the next several slides, we're going to go into kind of the a series of slides that will go through some key proficiencies that I believe will foster and support strong career growth. These proficiencies kind of range from the technical aspect, your technical proficiencies, your continued education, um, being a problem solver, a critical thinker, strengths to strengthen your engineering judgment, um, being practical and keeping things simple, um, always remaining accountable to yourself and to others, and building strong relationships. Those are kind of the 5 key things that I think are fundamental for strong, solid career growth. So from the technical aspect, technical proficiency in geotechnical engineering requires a combination of education, knowledge, continual improvement of your skills, and practice or experience. And this combination enables an engineer to effectively address all the challenges that they encounter related to soil and rock mechanics, foundation design, slope stability, earth retention systems, or other geotechnical considerations. And it is a critical to become proficient with these fundamentals, obviously. And those fundamentals are related to kind of the field work, the lab work, your analysis and your design, and communication. So your technical competencies really should focus around those items. So what do I mean by fundamental principles? Well, know your basic theories, have a solid understanding of geology, geomorphology, and soil and rock mechanics. All 3 are essential. Often as geotechnical engineers, or just as engineers, we tend to dive deep into the intricacies of rock mechanics or project specifics. And we either overlook or we forget about the basic geological processes that can provide valuable context to many of the site challenges we encounter. So really why I kind of use this fundamental principles is always to remember, the geology and the geomorphology and not to overlook it. Start with a solid geological model for every site or challenge or problem that you come across, and that's imperative to start there. Then the field work, whether it's reconnaissances, explorations, or construction field reviews, proficient geotechnical engineers are skilled in planning and executing field reconnaissances, field explorations. We need this to gather a significant amount of data about a site. This can include ground truthing, walking a site and the surrounding area so you can visually assess the area for features of key geotechnical engineering significance. What's the geomorphology? What's the vegetation like? What's the existing development like? The terrain, the topography, etc. It also involves assessing and being knowledgeable in exploration techniques and soil sampling. How do you your test hole logging? What geophysical surveys are available and what information can that provide to you? What in situ testing is available and what information can that provide? Like our CBT testing or SBTs. And then construction field reviews also. They play a very significant role in developing a strong geotechnical engineer. Contractors are definitely not forgiving, and working in the field during the construction stage of the project can be extremely fast-paced and very demanding. Spending time early in your career in the field will help you see some of the solutions being implemented kind of in real time, see the problems that come up and how your superiors or your bosses or your colleagues are solving these problems. And that'll only expose you to more scenarios and situations to support your career growth, and help you really get better at problem solving, and communication. And one of the things I think is very important to remember, as I was told by my mentors, is that geotechnical engineers should be the most comfortable and the happiest in the field, whether you're in the mud, snow, rain, sun, at a drill rig, you get to fly in a helicopter once in a while. These are things that, make a geotechnical engineer happy. This is what they're passionate about. So geotechnical engineering in some starts by making good field observations, collecting detailed information from the field, witnessing or reviewing the various stages of construction so you understand the challenges, and then you can understand how these challenges can be planned for or overcome. So after your field work, one of the core competencies should be lab testing. Knowledge of laboratory testing procedures and interpretation of test results is crucial. Lab tests can be standard tests to complex, just from basic grain size, moisture content, Proctors, Atterbergs, permeability testing to kind of more complex tests like direct shear or triaxial or consolidation testing. So understanding or having a good understanding of how to sample, how you handle or process your samples in the lab, and how the tests are completed is very important and can provide invaluable insight to the behavior or characteristics of the sample. This hands-on experience also, with various materials in the lab, getting comfortable working with them, can give you practical information to help you fine-tune your ability to recognize test results later in your career, that may not be representative or may be abnormal or something that requires further investigation or review. So, your fundamentals, your field, and your lab testing, are all critical components to start with in your career. And then the stuff that we really go to school for is, the analysis and the design. So as the above skills are refined and developed and you practice, you can start getting into your analytical and theoretical skills, and they become more and more important to support your observations and your findings or your data that you've collected in the field and lab. Always remain and be systematic. Always refer back to your geologic model. That's very important. The combination of well-executed field and lab programs, detailed observations, and your application of the appropriate empirical or mathematical theories and concepts will help you develop a really comprehensive understanding of the site and the geotechnical challenges that might be associated with it. We always want to use appropriate technology and software to assist you with your evaluation and assessing your geotechnical problem at hand. However, we should be very careful and mindful on how that technology or piece of software calculates or performs its intended task. And yeah, I always recall my mentor saying, or that proverbial saying, garbage in equals garbage out. And so we should never forget that some of these tools, and applications, while very useful, can completely mislead you if not used properly or with care and intention. One of the other things should be is, don't be afraid of kind of the good old-fashioned hand calculations and drawings and sketches. I know our junior engineers and EITs here hear that from myself and other principal engineers in the office, but making sure you can do those hand calculations is important, and making sure you can draw by hand to scale following proper conventions is really important. And the reason is that this skill can be is extremely valuable, especially during times of intense pressure or when access to technology and software is not possible. And you need to make a safe and a sound engineering decision quickly, or you need to check your findings and your results. And I use the example of the landslides or the flooding, or geotechnical earthquake issues, where, in real world applications, you might be called out to assess these sites or these problems, but you have to make a decision in the field. Those are kind of the extreme scenarios, but even looking at projects in construction that may be a remote location and there's no cell reception, and you need to be able to make those assessments and communicate that to the contractors or the people in the field, and check up later with your supervising engineer. Um, these skills will really help you navigate those really high pressure, challenging times. And then the last kind of technical proficiency I included was communication and collaboration. Um, Effective communication skills are essential for conveying all the complex geotechnical concepts and findings to your colleagues, your superiors, your clients, your project team, other stakeholders. Proficient geotechnical engineers can communicate this technical information clearly and concisely, whether it's orally or in writing. So you want to make sure you remain accountable, accurate, and prompt with all your communications. And I think it goes without saying, but we should always be respectful, honest, and inclusive in our communications. Um, Communication should be recognized that the communicator is the one who's responsible and accountable to ensure that their message has been received and understood by a listener. So I think that's a key piece of advice to remember, because a lot of problems, whether it's with contractors or clients or colleagues, come from just misunderstanding or not following through on the communication. Um, I'm probably aging myself more, but I think in-person, face-to-face conversations are always the best. Failing this, phone calls or video calls are really the next best thing. And we should really treat emails as follow-up instructions or just documentation or confirmation of any meeting or verbal conversations that you've had. Text messages in a professional setting or Teams messages are becoming more and more widely used, and I think they're great, but we should really be mindful of how they're used and reserve them to simple tasks like, you're running late, or I confirm receipt of this, or I'm on site, or whatever short message you want to convey. And then another important aspect about communication is knowing your audience and tailoring your communication to your audience. Um, Contractors often don't care about the details, and you could give them step 1 through 10 and they'll glaze over and not hear anything you said. But the only thing they care about is how it influences their work or how they can get their work done. Whereas when you're talking to an engineer or maybe a sophisticated client, they're going to want to know, well, what are you doing in step 1, 2, 3, 4 through 10? So be familiar with that, and also be familiar with the various oral and written communication styles or document strategies. I think as engineers, we like to focus on our software, like our slide analysis, our settlement calculations, our site-specific response analyses, whatever it might be, but we forget that we have to convey this information and document it. And so knowing the differences between memorandums, letters, reports, and how to use them and how to clearly write is very important. So, at an early stage of my career, one of the best things my mentors did was to ask me to review some of their work. They recognized that while self-checking is always critical and you should always check your own work, having another set of eyes to review and check your work is invaluable, whether they're junior, intermediate, or senior staff, or maybe non-technical staff. And they also recognized that the importance of this was also to develop another form of communication or collaboration, because one thing I think junior engineers stress about is having their work checked. So don't be afraid to have your work checked, redlined, multiple revisions. It's just going to happen. It's the nature of the work. It's part of engineering, and you shouldn't take it personally because it's not a reflection of your inability or something that's wrong. It's a form of feedback that will help you improve and strengthen your technical proficiencies and ultimately your engineering judgment. So that process is very valuable, whether you're junior or senior in your positions. And then lastly, in your proficiencies, you want to always continually learn. Geotechnical engineering is a dynamic field with ongoing advancements in technology, materials, methods. So proficient engineers need to demonstrate a commitment to lifelong learning and stay abreast of new developments through continued education, professional development activities, and participation in professional organizations. So the second set of proficiencies, I guess you could say, is the problem solve, critically think, and strengthen your engineering judgment. One of the most valuable aspects of my undergraduate and graduate degrees was, in many years later, recognizing that they taught me to problem solve and critically think. I think we can all agree that any engineering graduate can read a book or a reference and learn a specific topic. So we've all proven this by completing your degree or your degrees. So continually reminding yourself or following the steps to problem solving should be kind of at the forefront. You should always make sure you understand the problem, you identify the root cause of the problem, generate possible solutions, evaluate those solutions, and then select the most appropriate solution or provide a recommendation of what you think the most appropriate solution is to your colleagues or your superiors or your client. And then once that's selected and agreed, implement it, monitor it, reevaluate it. Geotechnical engineering, like I said, is very dynamic, so we need to continually reassess. And then once that's solved or completed, determine any lessons learned and document those and remember those lessons learned. We should also recognize in geotechnical engineering that there's many different methods. We use the observational method, deterministic methods, and probabilistic methods. I think as engineers, because we're highly analytical, we tend to heavily rely on the deterministic and probabilistic methods because they're well defined. They often give us a very specific answer, and that answer can be readily compared to a code, a standard, or widely accepted practice. But we often forget the importance or the value of using the observational method in conjunction with with deterministic or probabilistic methods. These methods or this method is particularly useful in situations where behavior of soil rock is uncertain or difficult to predict, or where you have a really complex problem, because it allows us to adapt the design or your initial solution in real time based on the observed soil and rock behavior. So I think that's very important to recognize that geotechnical engineering, and this is maybe why a lot of other engineering disciplines struggle with geotechnics, is because of that observational method. We're heavily reliant on that at times. Develop your critical thinking skills. What are the facts? What are the known knowns? What are the hypotheses or the known unknowns? Your instincts, your unknown knowns, or the uncertainty, your unknown unknowns. One of my other mentors used to say this to me all the time, that if you know what you don't know in engineering, you can generally stay on the safe side of things. But if you don't know what you don't know and you're just practicing engineering, you can get yourself into a lot of trouble. So I think that's the idea behind the known knowns concept. And it's very important in engineering, knowing what you don't know so that you can work within your limit and seek that advice when you need it. Then we should always critically think and continually ask ourselves a variety of questions, such as, what are my assumptions? How do they influence the findings or outcomes of my problem? Have I applied the most appropriate relationship or theory to the problem? What are the limitations of the problem or the theory or the relationship or theory? Have I seen this problem before? Have others seen this problem before? If so, what did they do? What did they find? How did they handle it? What's the quality of the information? Are there any applicable codes or standards, guidelines that are related to the problem? And are your references reputable and reliable? Do they come from a good source? Becoming proficient at applying your experience, your expertise, and using sound reasoning to make decisions in engineering practices is very important. Good engineering judgment is an indispensable tool in guiding your decision-making processes, enhancing the effectiveness and safety of engineering projects. It's also the blend of your knowledge, your experience, your reasoning that helps engineers navigate the complexities and uncertainties inherent in geotechnical engineering practice. So the third kind of proficiency, I guess, would be to be practical, keep it simple. Engineers are problem solvers, uh, and we can get overloaded with too much information or a lot of information or a lot of details. So being practical and having the ability to step back from your problem or zoom out is very important. Being practical means finding the most effective and efficient solution that balances theoretical knowledge and real-world problems, ensuring that engineering solutions are technically sound, safe, cost-effective, and achievable within the given or encountered project constraints. I always laugh at this, but one of my late mentors used to say to me when I spend days agonizing over, a simple little problem or what was complex to me but maybe simple to him, and he'd say, "Matt, use the KISS principle. Keep it simple, stupid." And it always made me laugh because I would always ask him, like, "Why did you pause for so long when you tell me this?" And he would say, "Do I need to explain that too?" But the point of that is that just to remember to keep things simple and go back to basics. And when you, especially when you're spending an agonizing amount of time on a problem, this can often help you unblock what you can't get past and kick you back in the right direction, and helps you kind of get out of that law of diminishing returns kind of loop. I think I've got two more kind of proficiencies that I think are very important. This one is being accountable. Lots of information on this page, but being accountable means taking responsibility for your actions and your decisions and the consequences. You need to acknowledge your mistakes when they occur and take steps to prevent them or rectify them, prevent them from happening in the future. I think when you own your actions and you're accepting that they have an impact, whether it's positive or negative, and it shows that you're taking responsibility for those outcomes. So you can own your actions by, basically acknowledging them, admit what you did, whether it's good or bad, reflect on your intentions, accept the consequences, learn to grow from your mistakes. Mistakes are opportunities. If you made a mistake, learn from it, strive to do better in the future, communicate honestly, make amends if you've affected somebody else or a colleague or a project, and then take steps to fix that or repair that. And then always commit to improvement. Take proactive steps to improve yourself and your actions. Use your experiences to become better. By owning your actions, you demonstrate integrity, maturity, accountability, and it's a sign of strength to take. It's a sign of strength to take responsibility for both your success and your failures, which others always look highly to when you do that. And then the last one is really build your relationships, network, mentor, show gratitude and reciprocity. Surround yourself by like-minded individuals and people who support you and bring out the best in you. This should not be limited to your work colleagues, but it should include your family, your friends, your life partner. Relationship building is crucial to career growth and success for several reasons. It provides you networking opportunities. The more people you know, the more you can connect with, and the more opportunities you'll come across. It gives you access to resources and information, whether it's advice, more knowledge, industry insights. Having a network of trusted contacts can help you stay informed, make better decisions in your career. It gives you a support system. Colleagues, mentors, friends, they can provide you guidance, feedback, encouragement. Having people to turn to during good or challenging times can be invaluable and help you navigate any obstacles and overcome any setbacks in your career. It provides professional development. You learn from others' experiences. You receive constructive criticism and you gain insights or different perspectives. And you can improve yourself from those. Gives you opportunities to collaborate. Working with others, you can leverage their skills, the complementary skills between groups of people and their expertise. And you can tackle larger projects and achieve even more than you thought you could achieve, or more than what you could actually achieve on your own. Building trust, it provides building trust and credibility. When you invest time in your relationships, you demonstrate your reliability, your integrity, your commitment, and it enhances your credibility in the eyes of others. It also permits career advancement. Whether it's getting a promotion, securing a new job, or gaining recognition in your industry, strong relationships can significantly impact your career trajectory. And lastly, it gives you job satisfaction. When you cultivate good relationships in the workplace or at home, you're happier. Your relationships with your colleagues, your managers, you're more engaged, you're motivated, you're more fulfilled all around. So building relationships, I think, is a very important thing for any young engineer. It's fundamental because it creates opportunities for you. It provides you your support. It fosters your professional development, builds trust and credibility amongst others, and it contributes to your overall job satisfaction. For me, this is probably one of the things that I'm most grateful and the most proud of. And this is why I'm emphasizing this one, is when I look around, look around me day to day, and I think about some of the accomplishments I've achieved, all I see are strong relationships and people that support and encourage me to achieve my goals. And without those relationships, I could not achieve many of these goals. Really, at the risk of bragging, I use my life partner. I've been married for 15 years, two amazing daughters, a very close family. My business partners are kind of my ride or dies. My colleagues at work and in industry support me every direction I look, and they push me to new heights every day. And the clients that come back to us trust the work that we do and how we deliver it. So these are the things that I think demonstrate why building relationships or maintaining strong relationships is extremely valuable and promotes your success in your career. So I'll move on to the last section, and I think I've only got a couple more slides here. And it's about overcoming your challenges and building your resilience. So mistakes are an inevitable part of life and work, and they happen to everyone. It's how we deal with those mistakes that define our character and shape our future. So this section really kind of reiterates some of the stuff that we discussed prior, but it explores the importance of overcoming these challenges and learning from your mistakes and ultimately growing stronger, because that's what you want to do. That's why, as I said, mistakes happen. To address your mistakes, you need to understand them, normalize them. Mistakes are a natural part of the learning process. They signify that you're pushing your boundaries and trying new things. But every mistake should be a chance to learn and improve and embrace a valuable lesson from it. This is not to say to try and make mistakes, because as engineers, sometimes our mistakes can be very costly and have severe consequences. But it's to say that you should always try your best and work within your limits and abilities and capabilities. But sometimes when you're doing that, mistakes do happen, and you need to be able to move on and move forward from them. To help foster your personal resilience and cultivate and overcome your mistakes, you should always want to cultivate a positive outlook. Remain adaptable and develop the ability to adapt to any situation and bounce back from any setbacks. Flexibility is the key to moving on and to building your resilience. Always treat yourself with kindness and understanding. Don't be too hard on yourself when things go wrong. And lastly, don't hesitate to seek support from friends, family, mentors, colleagues. People, I think by nature, always want to help each other. They want to go out of their way to help. If they're not overwhelmed and stressed in their own particular tasks or problems, I find when you ask for help, people are always willing to give you help. And having that support system really will help you navigate through any difficult, stressful times or any mistakes. Um, and remember, mistakes are not the end of the road. They're just detours or paths to success. I think by overcoming them, you build your resilience and you can bounce back stronger, achieve new things, and continue your professional journey. Part of that, I think, is having grit, have guts, resilience, initiative, tenacity. Having grit is about the perseverance and passion to pursue your long-term goals, even when faced with these setbacks or challenges. It's about sticking to your goals with dedication and resilience, even when the going gets tough. Gritty individuals are not deterred by failure. Instead, they see it as an opportunity to learn and grow. So there's several things here. I think I listed 8 things about how to develop your grit. Set your goals, stay committed to your goals, practice your resilience. So don't become discouraged. Use your mistakes or your setbacks as learning experiences and move forward. Maintain a growth mindset and stay consistent. Find your passion. Find, if you're presumably your passion is geotechnical engineering, but find your passion within geotechnical engineering. Um, Seek support with people around you, as I mentioned before, and then always celebrate your progress. Sometimes that small reminder of how far you've come or how hard you've worked can mean a lot to motivating yourself. And just remember that developing grit takes time and practice, and it's about building resilience and perseverance over the long haul. And I think the final kind of words of advice that I'd have is to, and we like Venn diagrams, so find that win-win situation. I think if you create a win-win situation or a solution, whether it's talking to a colleague or addressing a geotechnical problem or talking to your boss because you're looking for a promotion or talking to a client, finding that win-win situation is always going to benefit you and the other people that you're working with. It helps achieve everyone's objectives. So that is something that I think is a very important skill to kind of develop and always consider in your career. So with that, I think I'll start to close the webinar or the presentation. So in closing, some of the key things that I kind of talked about was understand your role and the importance of geotechnical engineering. We play a significant part in society. Choose your career path and follow it. Stick with it. Develop your skills and be proficient in fieldwork, lab work, your analysis of design and communication. Continue developing these skills throughout your career through education and professional development. Be a problem solver. Critically think and strengthen your engineering judgment. Be practical and keep things simple. Remain accountable to yourself and to others. Build and foster your strong relationships, and overcome all your challenges and obstacles by building personal resilience and moving forward. Mistakes happen. Have guts, be resilient, take the initiative, and try to find a way to create a win-win situation. So with that, I'd like to thank everyone for your participation in the webinar. I hope you've gained some valuable insights or tips into being a geotechnical consulting engineer. And I think that basically concludes what I have to say, so we can move on to any questions, if any.
Thank you very much, Matthew, for sharing your insights and expertise on building a strong foundation for a career in geotechnical engineering. Your advice is very much appreciated.